Cha-ching. Aaliyah, can you do me a favor? Can you kill the middle switch for me, pretty please? Thank you. We left off on page 191. Oh, nice. Numbers 1 to 3. So, are there any questions?
1 and 2D.
All of 1 and 2D?
Or just 1D and then 2D.
1D and 2D?
2D and 3B.
3B, it's turning into a tongue twister. 1D, 2D, 3B. Anybody else?
2C and G.
2C, 2G.
No, 3C
Goodness gracious, 3C
and D.
and D. Holy macaroni. Well, we'll see what happens. We might have to table some of these, but we'll see. So page 191. All right. It's not funny. This is math class. Stop enjoying yourselves. All right. So let's start with 1D. What is 1D? Given the following functions, identify values of x for which that will have vertical asymptotes. Okay, so 1D is 1 over 2x squared minus 5x minus 3. What you need to do is factor this so that you can find out what would make it 0. So we do that. Okay, actually this won't be so hard. So when you factor it, I'm not going through the 2 times negative 3. I'm not going through those steps because there's very limited choices here. Like 3 is a prime number, 2 is a prime number. So the x and 2x has to be, now the 3, we just got to figure out where it's going to be. If it's over here, 2 times 3 is 6. And then 1 times x is 1, 6 minus 1 is 5. That's how it'll be. So, and it's got to be negative 3 and positive 1, 2 times x, 2x times x, 2x squared. This would be negative 6x, positive 1x. So negative 6x, positive 1x is negative 5x, positive 1 times negative 3, negative 3. Anyways, we've done factoring before, but this tells us what the zeros, x can't equal 3. X also cannot equal negative a half. And if you're not sure how I did that, think of 2x plus 1 equals 0, and then solve for x. 2x equals negative 1, x equals negative a half. So if x were negative a half, then what's in the brackets here would be 0. If x equals 3, what's in the brackets here would be 0. Both of those would make it an undefined function. The actual question says values of x for which that function will have vertical asymptotes. So it would be, I'm saying it cannot equal negative a half, cannot equal 3 for this, but the answer is literally x equals negative 1/2 and 3, because those are the equations for the asymptotes. Really long way around. I feel like I said way too much for that. Is that okay? Does anybody have questions for that? Who wanted this 1D? Is that okay?
It's a bit confusing.
Where did I lose you?
Well, I think when you factor it, it's like I did the factoring for C.
Yep.
1C,
Yep.
but that one kind of confused me.
It was just harder to factor.
Well, I didn't factor it because
Oh, okay.
I didn't know.
Oh, so you just kind of played, like for C, you played around a little bit to find it, or?
Well, I just C. No, C. I like got that right away.
Did you factor it, or?
Yeah, I factored
Oh, okay.
it.
So it was just tricky to factor this one.
Yeah.
Oh, okay.
Why did you have to find the 1/2?
Why did I have to?
Couldn't it just be 3 because you did like in the original it was function of x equals 2x squared minus 5x minus 3.
Yep.
If you plug 3 into where all the x's are,
Yep.
it would equal 0.
Correct.
So why did you have to do?
Because that's another 0. So if you plug in 3, it equals 0. If you plug in a negative half, it will also equal 0.
Okay.
If you were to throw this into Desmos, I'll show you quick. Come on. Oh, mama. Okay, Desmos, come on, load quickly, please. Dun, dun, dun. So 1/2x, ha 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 ha. Shut up. 2x squared minus 5x minus 3 minus 5x minus 3. So one of those x equals 3, that was the one that people saw a little bit easier. X equals -1/2 is the other one. So that's where the asymptotes are. It's where the zeros are. That makes some sense.
Kind of.
Evan, is it a little bit better? It's the factoring that you might need to kind of touch up on. Where do I go from here? Okay. Moving along to 2C says what? Given the following functions, graph each function and its reciprocal. X squared plus x minus 6. Okay, x squared plus x minus 6. So you can do this with a table of values, which is one way of doing it. When you factor this, tell you a little tip. When you factor this, so this becomes y equals x plus 3, x minus 2. These are the zeros. So where this is where there'll be an intercept, like so when you actually graph it, +3 and -2, and then when x is 0, that's how you can figure out the y-intercept. When x is 0, it's just 3 times -2, so it's -6. So this gives you kind of a rough idea of where things will go. And really, if you have those 3 points, that's all you need. And I know I'm telling you stuff that we haven't actually gone over just yet, but it's easier this way. You know, the textbook, this stage of the game, they want you using a table of values. But when you can find the zeros, when x equals, oh, I did this backwards. When x equals 2 and y equals -3, those are the zeros. To find the y-intercept, that's when x is 0, right? Like this point right here is 0, -6. We know that because we plug 0 in for x. You can just do it up here. 0 plus 0 minus 6 is -6. And that's where the y-intercept would be. It's so much easier this way, but I just haven't got to it yet.
Is that when you do like FOIL, you put 0 x and 0 where x is, and you just do FOIL? And
Yep, yep.
So to determine another point, you just do like -1 in for x.
Yep.
1. Okay.
Yep. And really, like these are the, if you have these 3 points, that's all you need. You don't have to, you know, plot 16 points, and especially with a parabola, and if it's not in square form, you might be like, I don't know where the vertex is, and you're kind of guessing, and you end up like literally putting 10 points here. You can, you know, you can start -5, -4, -3. It just takes longer. I don't know why I feel the need to write all these out, but I just did. So you can do that and it'll totally work, but you can also see how quickly I was able to do it this way. Who wanted 2C? Are you okay with that? Anybody else questions about that?
Confused when there's like a 1 before the x, like the second x, right, the x there. And so then you go 6 down from y and then 1 left. And that would be the point of the parabola.
If when it's in square form, it's not in square form this way.
Can you put it in square form and do that?
You can, but I haven't touched how to do it yet. Like if this was a perfect square, like if you got the question y equals x squared plus 6x plus 9, that's a square because this is x plus 3 squared. So right, this is in square form for us. This one is not.
Okay. So
But
you can't do that then. You can't go down 6 on the y.
the short answer is no. The longer answer is yes. you don't know how to do it yet. Like I haven't showed you how to do it. There is a way to change this into square form. It would be like y equals, I don't know if I can do this in my head, x. I think it's probably x minus 1 squared minus 6. Like this is probably square form, but there are steps to do to get there. But again, that's next unit. So other questions? Moving along, 2D. Or not. Never mind, that's terrible. 2D. So same general idea. Oh, and so this question was actually, this was given to us in 1D. Same general idea. Well, let's write it out. So it was y equals 2x squared minus 5x minus 3. So if we factor this, it becomes 2x plus 1, x minus 3. So this tells us where the zeros are. At 3, there's one of them, and the other one is at -0.5. So like here-ish. And then if you want to figure out where the y-intercept is, when x equals 0, crushes that, it's just -3 left. If you want to put the x's and zeros right here, you can. It leaves 1 times -3, so it's -3. So it's something like this. The vertex will be kind of in the middle-ish. So we have 1 point, 2 point, 3 points. If you want to figure out the vertex, just wondering how much I'm getting ahead of ourselves and messing things up. The vertex, remember the line of symmetry is right in between, is right in the middle of this thing. It cuts it in half. So the vertex will be right in between these 2 points. We don't need it right now, but I'm just planting a seed, I guess. So this is 3, and this is a half. So 3.5 divided by 2 is 1.75, and that would be the x value here, 1.75, and then I don't know what the y value is.
Wouldn't it be 1.25 because you have to take away half?
No, think of it in absolute value, like the distance from here to here would be 3.5.
Oh, but then the x, that wouldn't be.
Oh, you're right. No, you're right. Yeah, you're right. So 1.75 minus, yeah, you're right. 1.25, that's what you said? Yeah, you're right. And then the y-intercept, that's a different animal altogether. But, so that's kind of that's better. You can use table of values. Like I said, it just takes longer. There's going to be more steps, going to be more figuring. But if you find the zeros, those are the intercepts. And then you can find the y-intercept just by making x equal to 0. So this is graphing the function as it is. And then it also wants you to graph the reciprocal, right? So it's y equals 1 over 2x squared minus 5x minus 3. So if we do this one in red, our zeros are going to be our asymptotes. And then with this, it's easiest to plot a few points just to get an idea. It'll either be, so I could do this and erase it easily, but like one here, and then one down here, or the other way around. Down here, and then one up here. But you just need to plot a few points to get an idea. So if let's choose like x equals -1. If x equals -1, 1 squared, -1 squared is 1, 2 times 1 is 2. -5 times -1 is +5. So 2 plus 5 is 7. 7 minus 3 is 4. So when x equals -1, y equals 4. All I need is that 1 point to know that it's going to be something like this. Honestly, I could just leave it like that could be the only point. The other one will go here, and then one will go here. If we want a point just to make sure, this point here is at 3, so let's put in 4. 4 squared is 16. 2 times 16 is 32. 32 minus 20 is 12. 12 minus 3 is 9. So we're going to get one of the points over here is 4 and 9. You want to pick a point in here that's easy? 0 is the easiest. Put in 0 for x. I'm not writing all this down. Maybe I should be. 2 times 0 is 0. Minus 0, minus 3. When x is 0, y is minus 3. It goes through the same point. I was going to say who could wait longer. I can't. I've got things to do. Do you need anything? You're just wandering around.
No, there's 2 volleyball girls.
Volleyball's the worst.
You have a Zoom meeting
Yeah.
from 1 till 2. Why not do it here, the Zoom meeting? Okay? So that way you can go straight to volleyball.
Holy moly, I never interrupt any other teacher's
I'm sorry.
classes. I was bugging you.
Okay, so all set? No problem, right? Good.
Is this okay for 2D? You know what's interesting? I'll tell you this. I was gonna put this on Classroom, but I wanted to give the practice questions for different things because I know this is tricky. I wanted to give you practice questions ahead of time. When I went to the textbook that I used before this one, there are parts from this unit in 3 separate units. So I'm like photocopying certain parts of those other units and I'm crossing out questions that won't make any sense to you that we're not there yet and then ignoring others altogether. And I'm just wondering now if maybe this textbook didn't put this together as well as the other one was, as far as this stuff goes with the order and that. But at the end of the day, it's just tricky stuff anyway. Is this okay for 2D? Who wanted 2D? Is this okay?
Yeah.
Like I'm not expecting perfection right now, but if you're completely lost, then I want to stay with it. But you're okay for now?
Yeah.
Okay.
So if you put the 2x squared minus 5x minus 3, if you make that all negative, it would be the opposite.
Yep.
So you would be
Yep.
upwards.
You got it. Yep. All right, moving along. That was 2D. Let's go to 3B. Graph y equals f of x given. Why does it say it like that? That's weird. Anyway, so 3B, we have to do 1 over x squared minus 4x. Factor that. 1 over x times x minus 4. Bless you, I think. You're welcome. What this means, the zeros are at x equals 0 and 4. Do we see that? So that's where the asymptotes would be. Oops, there's that thing in the way. That's where the asymptotes would be, because that would make this undefined. So at 0, so that's a nice one right there. And at 4, 1, 2, 3, 4, you guys will have graph paper. These are where it's trickier when it's right on the axis, but these are where the asymptotes would be.
How does putting a 0?
Because if x is 0, 0 times whatever's in these brackets, it's going to equal 0. So it becomes 1 over 0. Okay. And so like Nathan noticed, it's going to be this way because it's positive. And you can pick a number to plot just so you have 1 point on each one, which is not a bad idea, just to make sure. So if we try x equals -1, if x equals -1, -1 times, or -1 minus 4 is -5. -5 times -1, +5. So when x is -1, somewhere over here, it's going to be somewhere up there. So we know that just kind of verifies everything, but let's keep going. Let's say when x is +1. 1 minus 4 is -3. -3 times 1 is -3. So when x is 1, it's going to be somewhere around here. And one more, 1, 2, 3, 4, 5. So we'll put in 5. 5 minus 4 is 1. 1 times 5 is 5. So around there, it's, somewhere around there. I drew this quick and sloppy, but you get the idea. Also, I forget to do this because I'm lazy maybe. Put the arrowheads on. Put the arrowheads on when it's necessary. Every once in a while, it's not, but almost always is. Who wanted 3B? Was that you, Nathan? 3B?
I don't think so.
That might have been me, because I had a circle, but I
Okay.
actually had it
Okay.
right.
Okay. Anybody else? Are we okay with this? 3C and D. These were Nathan, right?
Yes.
Oh, hang on. 3 wants us to graph y equals f of x, not the reciprocal. So for this, makes it a little bit easier actually. Let's use black, but like, so y equals x squared minus 4x. We have our zeros here and here. That's where it's going to go through. And so this will be your parabola. That's how they're related. Oops, I missed this. This should be right here. Sorry, should be where the asymptote is. That's why you use pencil. So I graphed the or the reciprocal, but we're supposed to graph the original function. And that's the nice thing about Desmos, because lots of times the back of the book won't have, like the answer key won't have, I'm not going to look it up, won't have graphs, or if there's, you know, questions like that, you can just punch it into Desmos and make sure you got it. Okay, 3C, black or red? Let's switch to black. So it gives us this graph. I'm just going to show it instead of drawing it, which is terrible, terrible quality.
Questions is so bad.
Oh, it's unreal, like with technology that we have. Anyways, there's one asymptote. That means there's 1 0. That means there's 1 0. And also remember that the ones, and it's should I? Well, I'll use the marker. When y equals 1, it's identified those for us. That's what it goes through. There's one asymptote. It means it's going to be a straight line. And it goes through those ones. Remember, the function, when y equals positive and negative 1, it's the same for the reciprocal, which is another kind of easy way to, you know, remember when you're drawing these things, because the 1 and the negative 1 will be the same. So for this, we're told that the zeros, hang on, zeros are at, there's only the 1, which is x equals 2. And then y equals 1 at 0 and 1. Y equals negative 1 at 4 and negative 1. We just got to draw our line through those points. One asymptote means it's not a quadratic function. So x equals 2. 0 and 1. So it's like here, and then 4 and negative 1. 1, 2, 3, 4, and negative 1. So it goes through those points. But you're going to use a ruler, you'll have graph paper, and you won't miss the points. And if you do, you'll have a pencil, and you'll erase it, and you'll do it properly. Is that okay?
Yeah.
Do you need me to do D as well?
I
I might as well, because it's quadratic. No? Does anybody want me to do
Like,
3D?
You don't have. I was trying to find the formula.
Oh,
all the
okay.
time,
Oh,
instead of
yeah,
just, like,
no,
Going through the.
Yeah.
steps and
yeah,
however you say it.
yeah. No, you just got to kind of find those, the ones and the zeros. Anybody else want me to do anything else, or just move on to today's lesson? All right. I know it's tricky, my friends. I feel it in the room that this is not the favorite part of pre-cal this year. Oops. What do you mean part of that? Never seen that before. Okay. That is so strange. I've never seen that. I can't make it bigger right now. Sorry. You need me to read it to you? I'll try one more time. Present. I've never seen that before. Oh wait, show anyway. Let's try that. There you go. Oh, I know why, because there's a little graph picture there. Show it in a second. I don't know if I mentioned this to more people, if it was recorded or if I was just talking with Ada or something, but it's a little bit downhill from here, like for the rest of the year. If you're thinking, man, this is so hard, it's getting nice outside. It gets easier from here. You want me to shut the door? But mostly so Mr. Tate doesn't come back. He doesn't know how to work doorknobs. Art teachers, am I right? Just kidding. Shouldn't say stuff like that when I'm recording. Loading. Just not gonna go. Diagram is probably the best part of this slide, to be honest with you. The visual learners anyway, it's so much easier for me to see it. Is anybody still writing? We're good? All right, so what's not loading here? Oh, it's not showing at all. What a pain. All right, Desmos. It's your turn. Let me first close this tab. I don't want it there. Okay, so if we have y equals x, straight line. Straight line goes to the origin, the y-intercept is 0, slope is 1. This point is 2, 2, this is 4, 4. I guess I can click on it, and so on and so forth. Really straightforward. Now the absolute value, y equals, the absolute value stays positive. So this is perfectly in line with the other one, as you can tell. But anything that's negative becomes positive. So this point here is -2, x is -2, y is -2. Well, the y has to be positive. So x is still -2, but y is +2. It bounces off. It's a mirror image. It's a reflection, however you want to think of it. And that goes for anything. Like, so if I have like x, 2x plus 4, or let's say +2 just to keep it lower. If I put that in here, 2x plus 2, that didn't work. So just imagine it goes, it's the same right here. It's the same where y is positive, but right here, it'll bounce and it'll do the mirror image of this. So this point right here, -4 and -6 will become -4 and +6. And so when you're graphing, one of the easiest things to do is just find another point on this line. Like I said right there, -4 and -6, put a point at -4, +6, and then you just draw a straight line from here to there. You don't have to do 7 points and connect the dots. Just put a point and then draw a line through it. So that's what didn't load. I don't know why it didn't, but cool. Questions? All right. When I'm kind of scribbling on my sheet, would you guys prefer I did it on graph paper? Would that make it clearer, better, easier for you, or do you care? Sound like And as always, if you want or need graph paper, just take. I've got lots. I've got stacks in my office. Is everybody done writing? We're good? We're good? All right, so I said we're gonna walk through page 194 together. So let's have a look at that. Okay, so this is the textbook. Now it says, if it shows up, I want something skinnier to point with. So if we look at the graph of y equals the absolute value of x, we already saw that, so it just bounces right at the origin. Just this giant V. Y equals absolute value of x minus 2. Everything stays the same except that V drops down to 2 points. Does that make sense? If anything doesn't, yell, please. Now it's showing translation 2 units to the left. So y equals x plus 2. Remember, it's because we're still doing that kind of opposite day thing. So that it's that V at the origin, but now it just moves over, I guess for you guys, to the left 2 points. Now we're talking about the stretching, the 1/2. So it's the same thing, except it's going to be flatter, like it'll be compressed. So when we say stretched by 1/2, it's like if you were stretched, never mind, that's not going to make sense. It's vertically compressed. See, so the arrow shows it was kind of like this, but it gets flatter.
It gets flatter?
Yeah, it gets more shallow. Yes. So what that means is, it's easier to show on Desmos. Fine. How do I get out of this? Yep. exactly. So let's just keep it at y equals x. Oh, here. What in the world? What was it? Half? What is going on up here? So if you look, what did, like you, I think you said it, Sadie, like if it was at 4 goes to 2, that's exactly what it is. The original is at 4 for the y value. The y value is halved.
I'm just confused because it says half and then it shows y equals 2 times the absolute value of x.
I think you're looking at one lower than we're at. We're looking at y equals
Oh.
1/2.
Yep.
Okay. Comes in late, doesn't follow instructions. What am I gonna do? His attitudes. Yeah, and so yeah, so this is the one that you were talking about. And see, I think I had told you, a horizontal expansion is a vertical compression. And the book, which I don't like, it kind of alternates between saying that. I wish it would just stay vertical or just stay horizontal, but whatever. So a horizontal compression by 1/2 would be a vertical expansion or a vertical stretch. So it'll be, now it's twice as high. So it's going to be the reverse of this diagram that we see here. If it's like this, then it goes more steep. And then lastly, the negative. So yes, this part is absolute value, but now it's making everything negative. Before, where everything is positive, so it's this b that's at the origin. It's got the 2 in front. It'd be better if it didn't have the 2 in front because it's also going to be skinnier, but whatever. It's going to flip down now. So it's the opposite of the absolute value if they're throwing a negative on the outside of it. Are we okay with that? All right, examples, page 194, 195. So it says sketch the graphs for page 195. It says sketch the graphs of y equals f of x and y equals the absolute value of f of x on the same set of axes. So I'll use graph paper for this without using a ruler. This is page 195. Okay, so the first one, y equals 2x plus 5. Y equals 2x plus 5. So the slope is 2. The y-intercept is 5. Oh, this thing. The slope is 2. The y-intercept is 5. So 1, 2, 3, 4, 5. And it's positive, so it's going to up and to the right. And so I realize now, like, it's been a while since you guys have done straight line graphs and stuff. So relatively straightforward, but you have to jog your memory a bit. Slope is 2. That means it's a rise of 2 over a run of 1. So it does this kind of pattern. Do I have a ruler? Yes. So that's just drawing the line first. Are we okay with that? So now the absolute value, actually I don't like this green one. Y equals the absolute value of 2x plus 5. We can pick a point down here. So let's have a look at this point right here. It's 1, 2, 3, 4, 5, 6, negative 6, 1, 2, 3, 4, 5, 6, 7. So it's negative 6, negative 7. That means it'll be negative 6, positive 7. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right there. That's all I need. I'm going to draw right from this point. Even though it's like a half is 1, 2, 2.5, negative 2.5. Doesn't matter. Sometimes it'll land perfectly. Lots of times it won't. Get used to it. And the idea is that it's also here. We could draw maybe a shadow of it a little bit. It's not going to be the same also because I'm using big thick marker and whatever, but you can at least see it a little bit, that's where it's supposed to go. Cool, 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 cool. Questions? Now the parabolas are a little bit trickier, as you might imagine, but you'll probably get the hang of it pretty quick. So let's do one of those bad boys. I'll draw this out first. Wow, that's not straight at all. Yeah, that's terrible. I have a ruler right here. This big vertical S curve. Yeah, that's good teaching. Just imagine it's straight. Oh, that's beautiful. I know I enjoy math a little too much. I tell you, I worked with a guy who could cry talking about the beauty of math. Did I tell you guys about that? I ended up working with him at Glen Lawn. Really nice guy, super nerdy, in a good way, mostly. And I said, hey, can I, because it was my first time teaching high school forever ago. And I said, can I sit in your room first day, just see how you introduce things? He goes, yeah, sure. And so he's got a leg up on a chair or something. Because I remember he was always like, oopsie, oh no, that's my cord. He was always like button-up shirt, pocket protector and stuff. He had the mustache. And I remember him kind of leaning on his knee and he's like, math has utility and beauty. And I start laughing because that's funny. He was serious. I thought he was joking around. I thought, oh, this guy's pretty cool. He was serious. It is so beautiful, it makes him cry. If you've ever seen the movie A Beautiful Mind, probably not because I'm old, there's this guy who was just a math genius. And he was always like turning social situations into math equations and stuff. It's like, I couldn't focus on the movie because I just saw this guy that I used to work with, Dave Long. It's like, that's Dave, man. I can't focus on anything else. Okay, so we have, it says sketch the graph of y equals x squared minus 4. So we have y equals x squared minus 4, the absolute value. Now, it helps to draw the original first. So the original, I'll do that. Y equals x squared minus 4. We factor that, it's x minus 2, x plus 2, and I'm running into the graph. I'm probably going to have to go over this. X minus 2, x plus 2, that's where our zeros are. Okay, so it's going to go through negative 2 and positive 2. And when x is 0, y is negative 4. 1, 2, 3, 4. So this is where that graph is going to go. And so a smooth curve, and you can do this with a pencil. So if you screw up, like I'm probably going to do, that's gross. Anyways, you can erase it and do it over again. So that's what the original would be. With the absolute value, anything negative has to become positive. This point right here is 1, 2, 3, 4, negative 4 and 0. So it's going to become, that's not negative 4 and 0. What, is this my first day? 0 and negative 4. What it's going to become is 1, 2, 3, 4, and 0. So the absolute value graph follows this, but then it bounces. It gives the mirror image of what it would be there. What? Thank you. I just go too fast. I like the tone, 0 and 4. So it should be kind of a mirror image. I know that isn't, but this was a nicer curve. I'll just wreck it if I draw it. Does that make sense? So it's easiest to start with the original and then make the change. One more example. This example's tricky, so it's good that we do it. Am I okay moving this? Does anybody need this? Anybody have questions? Now, sometimes I don't want you to kind of see the answer in the textbook because I think that kind of takes away from your problem solving and stuff. But this one, it's worth, while I draw a couple things on here, it's worth looking at the steps and how it does it. So feel free to have a look, and then we'll create it together. Success. He needs to sleep. That's okay. All right, so the first thing that we're supposed to do, maybe I'll do it on a piece of paper on top of this. First thing that it wants us to sketch the graph of y equals absolute value of -4, x minus 2 squared plus 4. So it's throwing everything at us. So it's all of a sudden, there's lots to do here. If this wasn't an absolute value, we would know that, well, I'll just do it this way. So let's start with y equals -4, x minus 2 squared plus 4. Okay, so here the vertex is 2 and 4. Okay. And when we draw it this way, also notice that it's negative. So it's going to go down. And it's tricky here figuring out what the zeros are. And because this is using graphing technology, I'm okay if we kind of play around with it a little bit. But ideally, you're going to do a table of values as you need. Figure out those zeros. We want to find where y is 0. If we put a 2 in here, that makes this whole thing 0, but then it's 0 plus 4. So we can have that if we want. When x is 2, y is 4, although that's the vertex. But if we want to make this whole thing -4, we make this whole thing -4, -4 plus 4 is going to be 0. So to make this whole thing -4 would times 1. What makes this 1? If x equals either 3 or 1. Can you see that? Because 1 minus 2, -1, -1 squared is +1, -4 times +1 is -4, -4 plus 4 is 0. What did I start with? 3? No, I started with 1. If I start with 3, 3 minus 2 is 1, 1 squared is 1, -4 times 1 is -4, -4 plus 4 is 0. When we find our zeros, it just makes it way easier. So if we graph this, x is 3 and 1, put the vertex. So I'm going to graph in black y equals -4 times x minus 2 squared plus 4. Our zeros are at 1 and 3. The vertex is at 1, 2, 1, 2, 3, 4. We can also figure out if we want what the y-intercept is. I'll do it over here. So when x equals 0, that'll be our y-intercept. So -2 times -2 is +4. 4 times -4 is -16. -16 plus 12 is plus 4 is -12. So 0 and -12. I know I'm going fast, but I feel like I need to at this point because you can figure this out after if you need to. But I will slow down if you stop me. If you have questions. I feel like a comedian bombing right now. The room is just dead energy. Everybody's like, just end it. Just call it. So -12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it really goes down. Now, part of the reason is because it has this vertical stretch. So it's going to be long and skinny. We think of symmetry, then there's going to be another point there. And then we draw with a smooth curve as always. Oh, help me. Well, it's not the worst thing I've ever done in my life. So you have this. Well, that's ugly, but whatever. So you have this parabola. Now, if we want to do, because we must do the absolute value, y equals, all of this is absolute value, all of it? Yeah. Negative 4 times x minus 2 squared plus 4. Absolute value, everything bounces. It bounces, oh, I missed that point entirely. Everything bounces from this axis. So this point right here is 0, 0 and negative 12. I don't think I have enough here. So 0 and 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, thank you. And then same with this point, which is just 1, 2, 3, 4 over. So we can go 1, 2, 3, 4. So now these 2 points, this is all good. This here stays like that, and then it bounces. I've talked about like a smooth curve, absolute value, you're going to have a jagged edge. It's a hard corner. You don't have to do some fancy little curve here. It bounces off. That's all I got for you. Questions? We have one new lesson on Monday, which I don't think is crazy. And then 2 days to study, Tuesday and Wednesday. So 1 day in class, 1 day out. Test Thursday. Sorry, physics people, we got 2 on Thursday. Bless you. Any questions? Anything you need me to go over?
Can I have your paper?
You can have them all, sister. I used to ask, and then people started saying no because it's all recorded, but yeah, knock yourself.
There's a lot.
Yeah, yeah, it was. Oh, hey, Sadie, not this one.
Sure.
Kate, my friend, do you have any questions before I end this this gong show? I guess not. All right, we'll see you all later. And by all